All right, parallelogram. So first we're just starting out with a regular rectangle, doing the base times height, knowing that that's how we do solve, and 3 times 4 equals 12. So that was the area of just a regular rectangle. Now we're going on with a little bit of a different parallelogram. So first thing I'm going to do is the same thing similar to the triangles. I'm just drawing a rectangle over a line that I see splits it in half. So I'm just tracing that here. Counting out my boxes, it's a 5 by 3, so it's going to be a rectangle with a 15 area, but of course we're dividing out that side that we don't need, so it's going to be 7.5. Then I'm going to shade out the area that I didn't use and put in the area for the little section. Then of course I'm going to come back in and do it to the other side. So I notice that there's another line that goes through in a separate rectangle. So I'm going to do the same thing. It's the same rectangle, so it will have the same area because it will be 3 by 5. And then we will divide it by 2. So it's going to be the 7.5 once again. And I am just shading out again that portion of the rectangle that I didn't use, and drawing that line over the other triangle because I realized that that wasn't there and it was driving me nuts. So 7.5 in both, but if you can tell, there is a little section in the center there that we've used twice. So we are going to go ahead and subtract that from the total. It's a 1 by 3, so 1 times 3 for the base and height is going to give us that area of 3, and we will just subtract it from our total. And finally, we're going to go ahead and add and subtract everything. So we'll do the 7.5 plus 7.5 minus 3, and it'll give us that area of 12, similar to the first rectangle with the same area. Then we're going to go ahead and jump into our next parallelogram, which again is similar. It's going to have the same base and height of 3 and 5. But again, I am going to break it up just to visualize a little bit why it is the same. So I am first just realizing that diagonal line is going to break up this rectangle that I'm drawing over it. And I'm just writing the 3 and the 2 base and height for that individual rectangle. 3 times 2 will be 6, and once you divide that in half, it is going to give you the area of 3. So 3 will be the area of that inner triangle, and we're shading out the portion that we are not using. Again, we're going to split the other side that divides a rectangle in half. It'll give us the exact same base and height of 2 and 3, and the exact same area of 3 in the middle. Finally, I'm just taking that middle section that hasn't been accounted for. It is also a 2 by 3, but we aren't going to be splitting it since we will use the entire portion of it. So we are just going to do the base times height for that area, and it'll be 6 right in the middle. Finally, we're just going to need to add up those 3 totals of the area. So when we do that, we're going to go ahead and get to 12 once again, similar to the other prior 2 parallelograms. So it all just kind of taught me that a parallelogram will just be the base times the height to find the area, regardless if that vertical line isn't going to be straight, because I will show in a picture that if it could, I would shift over so that the vertical lines were the same and the horizontal lines would meet up perfectly.